Professor J. Hayavadana, Vice Principal and Head Department of Textile Technology, Osmania University, Mr. N. Giribabu, FIE Compliance Head, DGM Mohan, Spinning Textile Private Limited, Dr. NVS Raju, Professor and Head Department of Mechanical Engineering, JNTU Hyderabad, Mr. Pradeep Kumar, Department of Mechanical Engineering, Kamla Institute of Technology and Science, Karimnagar, Dr. Ram Mohan, Professor, National Institute of Fashion Design, Madhapur, Professor Dr. Ayodhya Kavita, MIE, Joint Secretary, IA Telangana State Center and convener of this event, Dr. G. Venkat Subbaya, Honorary Secretary, Telangana State Center, and galaxy of eminent personalities, past presidents, past chairmen, council members, committee members of Telangana State Center, and corporate members of the Institution of Engineers India, media friends, ladies and gentlemen, good evening once again to all of you. It gives me an immense pleasure to extend a hearty welcome to all of you to this technical webinar on a very important, vital, and interesting topic on Six Sigma for textile and apparel industries. I am glad to inform that the Institution of Engineers India is the largest multidisciplinary body, encompasses 15 engineering disciplines and has given a global platform for the engineers for sharing professional interests and the information on emerging technology and the contemporary science and technology. The Institution of Engineers has a membership above 8 lakhs and established in 1920 and headquartered at Calcutta and incorporated in 1935 under Royal Charter, and it has been serving the engineer fraternity for more than 102 years. And during this period of time, the Institution of Engineers has been intrinsically linked with the history of modern day engineering. And I would like to say a few words about Telangana State Center. The Telangana State Center was formed on 28th August of 2016 after bifurcation of the Westwhale Andhra Pradesh state, and the Telangana State Center of the Institution of Engineers has on its rolls more than 10,000 corporate members and covering 15 disciplines of engineering, and besides having a 19,000 plus non-corporate members in its fold. The Telangana State Center is one of the most active centers of the Institution of Engineers, which engaged successfully in translating the objectives, vision, mission, and the ideas of the Institution of Engineers India into practice. The present Telangana State Center was the legacy of erstwhile Hyderabad State Center of Nizam's Hyderabad State. And I am also proud to announce that the Telangana State Center has received Best State Center Award 18-19 and 2019-20, and also is the only center in India among the 125 centers which is holding a ISO certificate of 9001 2015. The Telangana State Center is playing a very, very important role in dissemination of information and emerging and contemporary technology among the engineering fraternity, and almost conducting programs, one pro event at least every third day. That means in 365 days, the Telangana Center is likely conducting more than 120 programs, and this is for the kind information of the August gathering. Since we are anxiously awaiting to hear the talks from the eminent speakers on textile engineering, I am limiting myself and hope that you will really enjoy the talks. And lastly, on behalf of the Telangana State Center of the Institution of Engineers India, and on my own behalf, I once again extend a hearty welcome to the President of Institution of Engineers, Dr. Hemant Thakreji, and Dr. Ranganath Kate Chairman, and Dr. Sadhan Chandra Ray, and the Chairman of the Textile Division Board, and all others, and including the Mr. King Suksen, who is toiling for making these programs very, very successful at the headquarters, and on my own behalf. And again, once again, I extend a hearty welcome again to all of you to this important. Thank you, one and all. Now I request Dr. Professor Sadhan Chandra Ray Saab kindly to address the gathering. Sir, your audio is not coming, sir. Ray Saab, your audio is not clear.
Sir, your voice is not coming, sir.
Yes, just a minute. Good afternoon, sir. Is it audible? Hello?
Yes, sir. Yes, sir.
Now, am I audible?
Yes, sir. Yes, sir. Now it is
Okay. Okay. So at the very beginning, I must apologize to yourself for being for being delayed to join the program. Actually, in fact, I was engaged in some other work. I totally forgotten the matter. So sorry. So good afternoon to each and everybody. Those who are in the speaker side or in the organizer side, as well as those who have been attending the program. So to be frank, I am proud of or obliged for getting the chance to say a few words in front of the learned gatherings. I became the chairman in the last year only, and this is the first webinar in which I am going to say only a few words. So I am lucky also, and particularly to Engineer Dr. B. Brahmareddy, Chairman, Telangana State Center, who has reminded me while I was engaged with some other work. So, sir, already he has given a detail about the Institution of Engineers, Telangana State Center, and about the program also. There are good number of learned speakers. So, as it is the subject related to textile, actually, basically, the main topic will be, I think, on different management technique as well as including statistics. But however, it will be applicable for the textile processes. So textile industry is the largest industry in our country just after the agriculture. So huge number of people are engaged. There are so many textile engineers, textile chemists, and many other, as well as fashion technologists, those who have been trying their best to upgrade the status of textile industry. It is today's industry is not like the industry which it was about 30, 40 years back. So many management techniques, statistical techniques, as well as electronical instruments or electronic sensors have been adopted into the manufacturing process. As a result, now we can achieve very good quality type of fabrics, and that too for the purpose of manufacturing or making our apparels or garments, whatever we say. So our textile industry is not only self-sufficient, India can, not only can, India has been exporting a good number of textile products and earning foreign exchanges, and particularly in the last 25 years, due to establishment of different fashion institutes, garment industry has flourished like anything, and they have been producing a very good quality, keeping in view the comfort properties of the fabrics, and for getting ultimately the final product fault-free. The attempt should start from the very beginning, that is the spinning process. Not only spinning process, starting from the collection of fiber. The basic material is our fibers, maybe cotton, maybe polyester, maybe nylon, whatever may be, man-made or natural. Fiber should be good enough, suitable for the purpose. Then it comes to the yarn spinning, then preparatory process, weaving, chemical processing, and then it goes to the garment factory for producing the garments. And in all the steps, in all the stages, sufficient preventive measures are to be taken so that we can produce not only the good quality, but also we can control the price, we can maintain the proper environmental situation without causing much pollution, as well as ultimately bring some profit to the industry, so that not only the owner, but also all the people can earn their sufficient salary for their maintenance of their lifestyle. So I think with these few words, I will conclude. And before the conclusion, I wish the learned speaker will throw lights on different aspects of the different management techniques and quality control processes, so that we can make products, fabric or garment, fault-free. Not only fault-free, it should fulfill our requirement. Earlier, only making of garment was not the main objective. Now we can, or we are in a position to engineer the fabric as well as garment as per our different requirements. It may be comfort properties, it may be environmental properties, it may be many other things. So I think the speakers will throw light on those aspects. With this, I would like to conclude with thanks to each and everybody attending the program. Thanks, sir.
Thank you, sir. Thank you very much for your kind address. Madam Kavita, Dr. Ayavardhan sir also joined.
Yes, sir. Sir,
You
yeah.
want him to call for this
Yes,
one,
sir.
or,
Yes, sir. First,
huh?
sir. First.
Okay.
Yeah. So first, I would like to give some details about the webinar, and then we'll call for the session.
Yeah. Please, you say few words about the webinar. Then I will invite Professor Ayavardhan sir.
Yes, sir. Good evening, everyone. Chairman Brahma Reddy Garu and Chairman Professor Sadhan Chandra Ray, sir. Very good evening to one and all. I am Dr. Ayodhya Kavita, Joint Honorary Secretary and Committee Member of Textile Engineering Division, IEI Telangana State Center. Would like to throw a light on today's webinar. Six Sigma is a set of techniques and tools for process improvement, and Six Sigma strategies seek to improve the quality of the output of a process. To emphasize the significance and its importance in textile and apparel industries, today we have four panelists. Professor J. Haivadana Garu, Vice Principal and Head Department of Textile Technology, talking on the significance and importance of textile and apparel industries of the Six Sigma, and Professor N.V.S. Raju Garu, Professor and Head Department of Mechanical Engineering, to talk on quality approaches towards Six Sigma, and Dr. Pradeep Kumar Garu, Assistant Professor from Kamala Institute of Technology, Department of Mechanical Engineering, to talk on cost of quality, and we have Mr. N. Giri Babu, Deputy General Manager and Compliance Head, to talk on quality management systems. I hope this webinar will emphasize the importance of this management tool to improve the quality in the production of textile and apparel industries. Thank you, sir. Now we are going to have a session by Professor J. Haivadana, sir. Brahma Reddy, sir, Miru.
May I request Professor J. Ayavadana sir, kindly to start your talk, sir. I invite
Yeah.
you, and it's over to Ayavadana sir.
Before sir starts the session, by the time he's preparing, I would like to just brief the audience about Professor J. Haivadana sir. Haivadana sir, are you there, sir?
Yeah, I am there, madam. I am
Yeah,
there
sir,
in
you
the
start
meeting.
sharing the screen, sir. In the meantime, I will just introduce you to the audience, sir.
No, there is a problem with the Zoom. It is not accepting at all. So I am opening through my mobile now.
Haha.
So it may be difficult to open this one, but
Screen.
I will open the PPT what I have got on my desktop, and I will be explaining. The audience may not see.
Yes, sir. Yes, sir. So I would like to introduce Professor J. Haivadana, sir, Vice Principal, Head Department of Textile Technology, Usmania University, Telangana, Hyderabad, Telangana. Sir did his education from. Actually, sir did his 10th from Bellary at the age of 13, and then at the age of 15, at a very early age, he joined engineering stream, and he did his BTech at 19 years, and he joined the University College of Technology in 1996 with his PhD, which he had completed in 1996. Sir did his MBA from University of Madras and PG Diploma in Personal Management and Industrial Relations from Vellore Christian University, and Diploma in Financial Management from Delhi University, Diploma in Business and Industrial Management from Calcutta University, Diploma in Training and Development from Delhi University, Six Sigma from Chandigarh University. So he joined Osmania University in 1996 as an associate professor, and he was promoted as a professor. And Sir is heading the Department of Textile Technology since 1996, and he had published 5 books from Wooded Publishers, London, and nearly 110 papers in national and nearly 20 papers in international journals. And Sir has supervised nearly 55 PhD theses outside Telangana state. And in University College of Technology, Usman University, Sir had guided 4 students for PhD, and in Agricultural University, he had guided nearly 10 PhD theses in the field of textiles. Sir had a patent awarded by Government of India in 2021 for development of handlooms. His specialized areas are all departments of textile mill production, costing, financial management accounting, industrial engineering and production operation engineering, Six Sigma and lean manufacture, and design and fabrication of textile testing instruments. As of now, he has designed nearly 8 textile testing instruments in University College of Technology, Usman University. Sir, we are very much happy for you being accepting to be a resource person or speaker today, sir. Now it's over to you, sir.
Thank you, Dr. Kavita Garu, for introducing me with spectacular information. I'd like to place it on record the Institute of Engineers Hyderabad, the regional center, for giving me an opportunity to share a small knowledge about Six Sigma. Unfortunately, today my computer is giving a task to me. My PC is not accepting to use Zoom. I don't know. So it is giving problem. I am using my mobile, but I may not be able to show the contents of my presentation to the audience. This is the issue. I will start my presentation. First of all, we would like to tell you what is the production function. Now the title is applicable for textile and apparel industries. So naturally what happens, the production may be in terms of fiber, whether it may be a regenerated fiber or a synthetic fiber, or it may be a manufacture of a single yarn or a double yarn, or it may be manufacture of a fabric on a loom, whether it is a conventional loom, hand loom, pit loom, shuttle loom, auto loom, or shuttleless loom, or it may be a process of converting a gray fabric to finished fabric by what we call it as the textile wet processing. All these are another example is there that starting from a gray fabric or a finished fabric, we have the conversion to garments for specific women garment, child garments, or men garments, etc. So in all these things, if one examines what is the basic engineering concept involved is, I can just indicate by an equation capital Y is equals to function of capital X. So this is the function. People may think that what is this equation, why it is to be remembered. Yes, it's a important equation. Why? Because Y on the left hand side is giving the output, and on the right hand side function of capital X is nothing but the input materials. When we say materials, what are the different M's? Money is there, methods are there, materials are there, men, whatever it may be. All these things put together, plus one more factor, which is generally not seen or not mentioned, what we call it as Z. So Y is equals to F of X comma Z. That will be the best equation for understanding what we call it as a production. Now there may be different types of production, maybe a continuous production, batch production, or semi-continuous production, etc. But whatever it is, when we say production, conversion of raw material to finished fabric. Yeah, there I just given a simple equation, but several hundred meanings are there, several hundred things are there in that. To know that, what is called as first very point comes in my mind is the production system. What I am talking, is it a push or a pull? Now, if it is a push, it is from the manufacturer side. I manufacture according to my layout, according to my resources, according to my capacity, but I am not understanding here the market. So I would like to manufacture the product and push it in the market. This is a bit dangerous system because you are not understanding what is called as customer's requirement. This is generally we call in Six Sigma as CTQ, critical to quality, the customer's demands. I need to find out the customer's demands. Of course, there are various tools will be there. One such tool is the voice of customer. So you get the voice of customer. Different ways are there to get the voice of customer. Whether it needs a perfectly simple fabric which is easy to maintain. Today, if person would like to have a fabric which is adjusting the environment, climatic environment, etc., etc., a person would like to expect bundle of benefits, but the cost should be low. Yes, we'll come back to that point, how to address this issue. Now, I was telling about what is known as push. Now, against this is pull. The customer would like to give his requirement, and we would like to work from re-engineering, or what we call it as back engineering. We have to work back and find out what is the requirement. In the beginning, actually it was in late 1970s, the Motorola companies started first this problem of solving the production through what we call it as statistical analysis. Thanks to two people who are the legends in the world, we call it a stalwart, and the one more quality control guru, we call it as Juran. These are the two people who has today told us what is statistics and how it is linked to the production process. Beautifully, one can understand the production by means of this statistical technique. 1987, Motorola officially started to launch what we call it as Six Sigma program. And I'm very sorry that I could not share you the pictures. In fact, I had collected good amount of pictures to show you my presentation. I am just trying to explain the contents of the diagrams through my desktop, through the mobile. Now, if one would like to understand a process, let us put a bell-shaped curve. Okay, a bell-shaped curve. And the bell-shaped curve may not touch the horizontal. A small gap may be there, about 1 mm or 1.5 mm. Let us try to move from left to right. If you'd like to move from left to right, then I can say that the central part is the mean and it's a bell-shaped curve I am telling. So therefore mean, mode, median all are intersecting at one point. Then to my left hand side, I have got negative values of sigma, and to my right hand side, I have positive values of sigma. So I am moving from left to right. Okay. So the minus to plus, irrespective of the sign, if I add it, I'll get what we call it as 6 sigma. And that is representing my 99.9999983% of the area. And very nicely, this represents 3.4 dpmo. That is what we call it as defects per million opportunities. One of the important parameter a 6 sigma is having. So one has to identify where is this process, whether it is a push process or a pull process, whether it is a continuous process or a batch process. Okay, let us take the example of cotton conversion. Let it start from mixing bale opener and end at ring frame. Now, let me redefine, because we have got the advanced systems like rotor spinning is there, air jet spinning is there, friction spinning is there. So draw frame sliver will be the raw material for us. And depending on the requirement, we'll be selecting whether we require 80s count, up to 80s count, we can go for air jet spinning, or we are interested to go for less than 14s, let us say 10s, select the draft spinning system, or up to 20s, select the rotor spinning system. Yes, you say whatever the system you want to select as a production of yarn production, and we need to identify where exactly the mill or the firm is working. We conducted a small study in a spinning mill. For this, we started our observations on the concept of what we call it as standard time. Standard time is a very important parameter. In apparel industry, it is called as standard minute value. We call them as SMV or standard assessment value, whatever you call it as. How far the industry is going with the standard minute value? Because what is happening is I have a target. So if I know the target and if I know the SMV, I can get what will be my production. Or in other words, I can find out what is called as the takt time. Of course, I'm all using the technical terms of Six Sigma because we started the concept with production. So naturally, all these times like cycle time, lead time, takt time, all these times will be involved in the production process. Now come back to that bell-shaped curve, very interesting curve. Now, if I say that the curve is more and more flattening, yes, there is an issue with variation. Now, why this variation is coming? You or me or somebody cannot control this variation. Variation will be there. Then is it inherent concept of a process? Yes, it is the inherency of a process. But the question is that to what extent this variation is there? Why should we talk about the variation? Because the variation will give you the imperfections. Imperfections may be converted in the form of defects, and defects may be go to an extent that they cannot be reworked, which we call in our statistics as scrap, and thus your yield will be less. Once your yield is less, what happens? Your overheads are there and your yield is less. Naturally, the cost per item will increase. So what has to be done? Very simple. You control this variation. You control the imperfections. You reduce the defects. And that is what today's concept of the Six Sigma concept is. You try to find out what customer wants. That is VOC, voice of customer. Just now I was telling you. Satisfy the customer and at the same time control the cost. For a fixed profit, for example, I can tell you the equation of the cost has to be changed. The cost per unit has to be changed. the cost per unit has to be reduced. For this, we need to control the process. As I was talking to you, we undertook a study of yarn manufacture in a spinning mill, cotton spinning mill. We took the observations of all the departments. Standard minute values were taken and spindleage hours were considered. And we found out what is the level of the sigma the industry is working. We want at 6 sigma level. Okay. What is that 6 sigma level? As I told you, 3.4 defects per million opportunities. Means the 6 sigma level indicates that if you take 1 million compounds, okay, 1 million units, you should have 3.4% of that. Means the output will be 99.99966% free. Against what we call it as 0.5 sigma. The 0.5 sigma will have only 16% output defect free. Means remaining 84% it is defective. See what a strange concept we are having. You are going to either southern hemisphere or northern hemisphere. So one hemisphere is towards 6 sigma, another hemisphere is towards 0.5 sigma. Very dangerous. So where do the industries normally do lie? And where they will say that in what level sigma they are operating? They may boast that they are operating somewhere around 4 to 5, but most of them they lie somewhere between 3 to 4. So this is what we observed in our observations. The manufacture of cotton single yarn using cotton system of machines, say using the Trussler blowroom line and the card and Fukuhara draw frame lines, we found Reiter machine works, the ring frames, we found that the number of end breaks in the ring spinning for 40s count was little bit higher, and whole picture was telling us that the industry is working with 4 to 5 sigma, specifically with 4.5 sigma. Of course, the industry management was not ready to share this information to the public, but we showed that this is the situation. So now what is the benchmarking? What you should do? Very simple. You go from 4.5 to 6. How to go? Identify what are the variations are there in each process. Now, to what extent these variations may be, of course, they may be in the form of settings or speeds or selection of the particular make. The particular make, when I talk, the Reiter machines or Trussler machines, like that, these are the different makes are there. They may give good quality, and we need to find out which is the layout suitable for the particular yarn manufacture. Don't forget to know about the ergonomical aspects. Very, very important. Any production process for that matter, that's what I was talking to in the beginning of my lecture. Y is equals to function of capital X comma Z. This Z is very difficult to understand. Very, very difficult to understand. Why? Because it has got gamut of factors. Okay. One of the factor is called ergonomics. What is that ergonomics? What is the percentage of humidity you are maintaining? What is the light? What is the ventilation? So let me identify those variations and get back to my concept of 6 sigma, in which if I take 1 million opportunities samples, if I get defects 3.4%, I'll be very, very happy to go ahead with the process. Now let us take a simple example. I have produced about 535 specific compounds, 535 garments, let us say, shirts of apple cut shirts. 535 I have determined. Let us say particularly S, because there are different types of sizes are there for me. S is there, L is there, XXL is there, M is there, etc. So yes, I have taken. and I found that around 43 were found to be defective. How could I say? I have my own barometer, I have my own instrument in which I can measure whether the kaja making is proper, buttoning is proper, selection of buttoning is proper, selection of stitch with a particular part of a shirt is proper, and whether the plackets are correct. See, all these things I have noted. And I found that 43 were found to be defective. So what did I say? 535 I selected and 43 were found to be defective. So how many were good? 492. Now let me calculate my yield percentage. 492 divided by 535. It's giving me 91.9%. Yes. Now if I would like to look at where I am at 2.5 to 3 sigma levels. Very dangerous. Very, very dangerous. So what I should do? Try to cut down this 43. Correct? Yes. Let me go back to the department. Train the workers. Here the training within the industry programs are very interesting. Whether it is on-the-job training, off-the-job training, classroom training, so many training, vestibule training, fine. I found out a new method of training with the training course so that the personnel has been trained and they were made aware also about the quality system. What quality is meant by that? Why should they stick to the quality? Who is the customer? Which is the market for us? All these things I have explained them. They understood, and because manual role is there, the imperfections, defects are there. If it is completely automated, something like robot control, I may not get all these things. But our Indian circumstances may not go for 100% automation. Chaliye, now with 43, I have reduced this defects to 21. What did I say? I have collected 535 in the beginning. 43 were defective. 492 were good. My yield is 91.9%. And my sigma current level is 2.5 to 3. Now I took a complete re-engineering, shop floor re-engineering, and I reduced the defects to 21. So now I got from 492, the number has been increased to 514. Okay, because 535 minus 21 is nothing but 514. So 514 divided by 535, I am getting 96.1% yield. So from 91 to you have come to 96. So now naturally there is an improvement in my Six Sigma level. From 3 I have come to 4. Yes, this is what I need to do. I have to find out from how I can improve from one level to the other level so that the defects are less. Now, if one would like to know how exactly these defects are related to the quality, cost of quality, a very important term. Generally, people do understand cost of the good quality product and cost of poor quality product equal to the cost of quality. Now, let us relate the defects per million opportunities with cost of quality. Okay. If I would like to say 6 Sigma, top Sigma, of course, today we've got 7 Sigma, about 1.45% of DPMO. Okay, people are not there enough today. Very few industries have achieved 6 Sigma, and there is a word of 7 Sigma already. Now, in this 6 Sigma, 3.4 DPMO, if I would like to find that I may lose only 1% of the sales against 25 to 40% of the sales if my Six Sigma level is 3. See what a dangerous situation is there. Where you are, where is 1%, where is 25%. Okay, so therefore we need to be very careful in the manufacturing process and address the letter Z. That fellow is a very typical fellow. We need to identify this Z. One such tool is what we call it as fishbone diagram. That is what we call it as the cause and effect analysis. Let us say a simple example for those who could not understand this word cause and effect analysis. I'll take a raw example. I started from my home. I I need to reach office. Okay. What are the different things I'll get? First straight line, left hand side leaving home, right hand side reaching office. Okay. And in between, I get a lot of interferences. What are those interferences? First is traffic. Second one is unprecedented some dharnas. Like that, all issues which I will get on the way to my office, these are all the parts of the bones. And I would have got up late. That may be one of the reason also. So try to address these points which I am telling you as bones. And this will constitute what is called X, comma Z. And what the Y? Y is you are reaching the office is Y. So X comma Z, again I am using that equation. I am really fascinated to understand this equation because beautiful equation. And Z is one of that letter, as I told you, use many models. One of that model is called fishbone diagram. We may also get new ideas by what we call it as brainstorming. Many things are there in brainstorming. One of the brainstorming activity may be 635. People may find that what is this gentleman is always talking about numbers. Yes, numbers only will play a game. It is a number game. Okay. 635, 6-3-5. I am not telling any house number or area number. What is this? This is nothing but 6 means 6 people will be there in the brainstorming situation, and they will consider about 3 different points to be discussed, and they will discuss for 5 minutes. You got my point? So 6 people discussing on 3 different points, something like production is very high, production is low, production is in between, that is medium, something like that. Or going for women's shirts, going for men's shirts, going for kids' shirt. Some problem, 3 different types of the issues, and discuss for 5 minutes. It is what we call it as 635. Okay. This is one of the tool which we can get some information about letter Z, because if you control the letter Z, automatically Y, the dependent variable, will be getting the values from independent variable, what is called as X. One more tool I can also give, Yamazumi chart. Okay. What is this chart? Yamazumi chart. Yes. This chart we call it as belt chart. Now we can plot a belt chart for various aspects of a particular process. Go back to the yarn manufacture where I took study of Six Sigma in a spinning mill. I will record all the aspects of technical aspects, economical aspects. Of course, we call it as techno-economical. Now, depreciation, what is the value loss? What are the overheads? What is the capital? What is the rate of interest? These are all one sides. Then what is the productivity? How much is the labor you are allotting? What is the waste you are getting? What is the production per 8-hour shift, etc., etc. Power, how much power it is consuming. All these things, I'll put it on a graph. Then I will compare different types of opportunities what I am planning. Either a kids shirt or a women's shirt or a men's shirt. Fine. And I'll get the answer. These are all what we call it as tip of the iceberg, because the time provided to me is very short. Okay. It is not a Six Sigma time. It is a very small time. So therefore, I need to be very much limited in my explanation. So these are the tip of the iceberg. I'm giving you some of the tools. Yamazumi chart is a very beautiful chart for us to understand. See, now come back to that bell shaped curve. हम नहीं छोड़ सकते उसको bell shaped curve को, because इतना अच्छा curve है वो. Okay. वो bell shaped curve, what you do, you push it from left hand side and right hand side. What happens? the central part will get steepening. Fine. That's where I want to say you that your variations are less. Now, if you'd like to address as variations, koi baat nahi. Otherwise, you please address in terms of lead time. Any apparel industry, any spinning industry, any wet processing industry, any weaving industry, you please note that you have a lead time with respect to the target. So how best I can reduce my lead time? Generally, this is one of the aspects of our vendor rating. Most of you, I feel that can understand the vendor rating and evaluation. So try to come back to this normal distribution curve, push it from left-hand side and right-hand side. It steepens. The peak will increase. Very nice. And thus the variations will be less, so that what happens, your number of defectives will be less and your productivity will be more. You are nearing to the customer because customer is interested. As I told you, bundle of benefits. Take a simple example of lipstick. Lipstick is a simple product. Women would like to use the lipstick. So many benefits they will be expecting. But what is the danger? Danger is that it is a chemical. Okay. So when it is applied to the skin, what will happen? What are the after effects? Of course, all these things the manufacturer will be knowing. He is not a small boy. So try to control the variations. One more example I'd like to give you. Variations. Because letter Z only I am concentrating from the beginning of my lecture. Now, let us take the landing of an aeroplane. Okay. And we have the runways. It all depends upon an airport with one runway, two runway, or whatever it is. Now, let us have a runway which is meant for landings. Now, how far exactly at the center of the road of the runway, the air flight will be landing? That is a question. If we would like to plot the points on different days on x-axis and on y-axis, the magnitude of this landing, either on one way or the other way, we can find that if all the landings are barabar, exactly accurate, then all my points will be on the line, central line, not on the line above the central line, not a line below the central line. Okay, that will be the best way of landing. So we have to give credential to the pilot. Very nice. Now come back to letter Z, and in letter Z, the question is that cost per unit is more. Yeah. Now why the cost per unit is more? You go back to a simple example of sizing. When you look at a sizing of any sort, whether it is 10 sort, 20 sort, 40 sort, all single yarn we do size. What is the problem here we find? In sizing, if people are aware about the weaving process, I can say that dead loss is the biggest challenge for us. We need to keep it as low as possible, but that will be as high as possible. Okay. Now we need to find out what are the various reasons to find this dead loss very, very low. Why? Because your cost per kg of sized yarn will be more. You have used X kg of the sizing ingredients. Who is telling? Your material management, that is store, is telling that we have used so many kg of the sizing material. And is it available on the yarn? Yes, who is telling? The desizing person has to tell you that how many kgs of the sizing material he has removed in the form of desizing loss. He may say that around 7.5% or something like that. And you feel that you have used several tons of sizing ingredients. Are kidhar gaya ye pura? Where it has gone? Now we need to find out a reverse engineering process. Starting from the storage bag, we need to find out the size supply lines, storage bags, pressure cookers, sow boxes, all the elements of the sow boxes, and we have to find out how many liters was prepared the size paste, how many liters was used Unfortunately, here one dangerous point is there. Those who know the sizing process will agree with me that when we maintain a temperature about 90 to 93, please note, we can't maintain 100 degrees centigrade because it is a open soap box, and every possibility is there for us to have a softener to evaporate. So how do you account why? You already taken the quantity of softener in the ingredient mixer, but when you find it on the yarn, you are not able to see it. Okay. So like this, the dead loss will be more. We need to control the dead loss. Therefore, my equation is like this. Cost plus profit is equals to price. Or this is the old equation. I repeat once again. Cost plus profit is equals to price. What does it mean? I am manufacturing a pen which is costing 8 rupees. I want to sell it at 10 rupees. Then the 2 rupees, when you express as a 10%, it is 20%, 10 rupees. 2 rupees expressed as 10 rupees, it is 20%. But 2 rupees, if you want to express as 8 rupees, it is 25%. Okay. So depending upon your profit, what is called as your selling price is there. I want to give a new equation now, Six Sigma equation. What is the Six Sigma equation? I want to have a fixed price. See, very, very important point I'm talking. Fixed price minus cost is equals to profit. So I am not disturbing profit. I want to have a higher profit. Now, which you have to target? Cost you have to target. Because fixed price minus cost is equals to profit. So target the cost. And when you target the cost, all these elements which are related to Z will be coming. This is what we call it as cost reduction, cost control. And this is achievable only when you have zero defects, quality control, total quality management. All this will be part and parcel of the Six Sigma. And for this, you need to have a team in the department. And why we are having different methodologies of Six Sigma, but one methodology is called DMAIC methodology, is very, very popular. D stands for define, M stands for measure, A stands for analyze, I stands for improve, and C stands for control. Okay? And many industries are there. For example, Intel Industries, HP, Honeywell, Texas Instruments, DuPont Instruments, all these are the people who have already applied the Six Sigma. Many companies in the world also, Apollo Hospitals, for example, in India, ITC Hotels, GRT Hotels, ICICI Banks, Bharati Cellular, Vodafone. I'm not an agent, please note, for all these companies. Just I have collected, they applied the Six Sigma. And that's how the Six Sigma is found to be very, very popular. Now, let me come back to various tools, what we are using in each stage. First stage is define stage. Here I need to define what is project charter. Project charter means what you want to produce. For example, I want to have 500 tons of polyester terephthalate. That is my current production. I want to go for 530 tons of polyester production. That is your objective or goal statement. Overall, your team members. And what is the CTQ? That is critical to quality. What the customer is asking. And what is your time lane? For example, 4 months, 3 months, 2 months, etc. Under which master belt you have been guided. All these things put together, we call it as the project charter. Then process flow chart, very simple. In this flow chart, we'll be using various symbols like operation, inspection, transport, store, delay, etc. So what it will give? It will give standard time. And standard time is such an important time. It will also tell us about how much time a unit consumes to be converted to a final product. Why? Because we have available time 480 minutes in a shift divided by SMV, standard minute value, will give me the target. Or if I know the target, for example, 480 minutes are available, but I have to manufacture around 600 items, then 480 divided by 600 will give me my takt time. Okay. Like that, we can identify what is the takt time. and I need to use SIPOC diagram, supplier input, then product output, and the customer diagrams, we call it as product or process, whatever you call it as. Then I need to have CTQs because lot of expectations are there. Simple example, anybody is finding to purchase or order pizza. Okay, what are the different CTQs will be there? Quality is one concept, cost is one concept, neatness or hygiene is one concept. Most important is delivery time. See, these are all the various elements of CTQ. Okay? Then voice of the customer, how we are getting the information from the customer. These are all the tools used in define. Let us go to measure. What are the tools used in measure? First is data collection. For this, we know statistics very well. Is it a individual data, primary data, secondary data? Then we need to use various diagrams. For example, box and whisker plot, stem and leaf plot we can use. A radar diagram I can use. Ellipse diagram I can use. Many things are there. Benchmarking I have to think. And gauge R&R I have to carry out. Repeatability and reproducibility. And finally, I should calculate what is my process sigma. Process sigma is related to your yield, and thus we can find out where are we. The next phase is analyze phase. Analyze phase, we need to ask questions why. Go back to the fishbone diagram. One example I was giving you. Ghar se nikle office ko ja rahe. Okay, now we need to put this 5 why. Then very first question is, why did I get up late? The reason is that alarm did not work. What is the solution? Correct the alarm. Like that, you ask each stage WHY, 5 whys, and you'll get the answer. And if you want to get more answer, you go for regression analysis, you go for time series, you go for Pareto chart, vital few, trivial money, you go for hypothesis testing, something like T-test, F-test, chi-square test. We'll get the answer for analysis. Next is the improve stage. Whenever I have to improve, you use design of experiments, how to conduct the experiment, what are the different levels of the experiments, how many parameters are there. For example, I have 4 parameters of a dyeing situation, something like dyeing temperature, exhausting agent, material to liquor ratio, and also the dye percentage. All these things I can use at 2 levels. One is minus level, another one is plus level. This is what we call it as 2 power n experiment, 2 power 4 experiment. Or also you can go for FEMA, failure modes effects analysis. We can also go for house of quality, what we call it as QFD. And the next stage is called control process. Whenever we talk about control, of course, we'll be talking about the network, CPM and PERT network, how they are useful. So that the farthest start of the fiber, today I have got the bales. I have started with bale management. Then I have spin plan. I know the production per machine per 8-hour shift. I know my efficiency. So how much time it requires for me to convert into cones. And if I receive cones, how much time it requires to convert into fabric. Put in the form of a diagram. That is what we call it as network diagram. And we can identify what we should be ready to do. Please note that Z is a very important parameter which is playing. And finally, we have to go for improving. In the case of improving, we have different types of the tools. Control charts are there. Cost saving has to be done. And a perfect control plan has to be done. So I would like to sum up my lecture because they have given only 30 minutes time. In that I have to manage, my yield has to be more. Okay, my points of not explaining should be less. So I need to explain more. And what I feel is that one has to control the various parameters called Z in addition to all the input characteristics and use proper tools so that we'd like to get more amount of the productivity. Not only that, the quality will be there because the customer will be very happy and the markets will be going ahead with the designed level of the output. I hope that this small lecture would have given you some idea about various types of factors controlling the production process. I once again sincerely thank Institute of Engineers and convener Dr. Kavita Ayodhya for roping up these programs and also asking me to give a small lecture. Generally, I give lecture for 2 to 3 hours. It's a challenge for me to give Six Sigma lecture in very short period. Thank you very much. Hope that you have understood and all the doubts can be aired to me so that I would like to clear your doubts. Thank you very much for your listening.
Thank you very much, sir. Though the presentation was not available on the PPT mode, but we could understand what it is and hope the audience also would have understood it. The questions will be taken in the last, sir, after all the sessions. And now we have a presentation. Now we have a session by Mr. Pradeep Kumar Garu, and I request moderator Rammohan Rao sir to introduce Pradeep Kumar sir to the audience.
Yeah. Good afternoon. Am I audible?
Yes,
Good
sir.
afternoon. Good afternoon. Am I audible?
Yes, sir. Yes, sir. You're audible.
Yeah. Thank you. I would like to invite Mr. Pradeep Kumar. Pradeep Kumar will be delivering a lecture on a cost of quality, if I'm not wrong. So he is working as assistant professor in mechanical engineering department of Kamala Institute of Technology and Science. He has submitted his thesis, PhD recently, and waiting for his certificate, final viva and certificate. So he authored books like Engineering Mechanics, and he contributed in the form of chapters in few books like Postgraduate Certificate in Inventory Planning and Warehouse System for Engineers, right? Safety Philosophy and Principles of Accident Prevention, etc. Okay, and he had authored many papers and received Best Paper Award at national level conferences, published about 32 international journals, published papers in 32 international journals, and attended 10 international conferences, and also 5 national conferences. I now invite Mr. Pradeep Kumar to start his session.
Yeah, thank you so much, sir. Thank you. First of all, I thank all the dignitaries for giving me this opportunity. Right. So can you please confirm, is my screen visible?
Yes, sir.
Yeah, thank you. Thank you so much for the confirmation. Yeah, a very good evening, all. In this session, we will learn the concept of cost of quality. So before going into cost of quality, we'll define what is quality. So the term quality has various definitions and various meanings, but we will look at very few of them. So quality is defined the fitness for the purpose. So any product that is developed or manufactured should fit for the intended purpose. And some other may define quality as the degree of customer satisfaction. So the products should ultimately satisfy the customer. Then we can say the product is of good quality. So some other may define quality as accuracy in meeting the specifications or design. Some other may define quality is meeting the standards or norms. Or some may define quality as degree of excellence. So these are the very few definitions of quality. Now we'll see what is cost of quality. Before we go into the concept of cost of quality, I have a line which I want to show you. Yeah, everyone can see the slide. That is, it is written, pay me now or pay me later. It looks very simple. It looks very simple, but The meaning behind it is very big. Before we understand the meaning of that line,
సరే
like
నాకు
to-
మార్నింగ్ పంపించేస్తే నేను నాకు అవుటర్లో వెళ్ళి చేసేస్తాను.
I would like to show you a small video. Then we will come back to the slides.
ఇంకోటి ఒకసారి రాజశేఖర్ నా బ్యాగ్ కావాలి, నాకు కార్లో అలాగే ఊడిపోయింది.
సారీ సార్, జస్ట్ సెకండ్. బ్రహ్మారెడ్డి సార్ మీరు మ్యూట్ చేసుకోండి సార్.
Well, it is a, excuse me. So it is a very old,
Pradeep
old
ji?
advertisement.
Mr. Pradeep,
Yes, sir. Sir.
your video did not play properly, sir. We couldn't hear anything.
Yeah. Actually, the video itself having a very low volume, sir. So I will explain.
Even there is a interruption problem issue also, I think.
Okay, I will play once again. It's a
There
1
is
minute
an
video. I
interruption
will play
issue,
once.
like, your signals are not continuous.
Yeah. So once I will play once again. Let's hope it will play fine. Yeah, it is just a 30 seconds video, which tells that it is a video related to the oil filter, the frame oil filter, and in the advertisement of in the year 1980s. So the advertisement is, you can see a mechanic who is repairing a car, and the car has a problem of replacement of a bearing. The main reason for the bearing failure is the oil filter, and the mechanic says, pay me now or pay me later, which means if you choose a better oil filter, you can avoid the failures. Or if you choose an oil filter of poor quality, again you need to pay me for repairs. So this is the concept behind cost of quality. So in few cases, some people define cost of quality as a cost to attain higher quality. Some other may define cost of finding the correct cost of finding or correcting the defective works. Still, some other may use the term the cost for running the quality department, but these are absolutely wrong. So I want to ask a few questions. Does high quality product mean higher cost? Does high cost product mean of superior quality? Does quality increases cost or cost increases quality? Or both cost and quality are proportional to each other? Absolutely, our answer should be no. We will get more clear idea at the end of this session. Few days back, I had visited appliances to buy a refrigerator. There I saw a customer who came to buy a refrigerator, and the conversation is conversing with the salesman. He asked to show the quality refrigerator, And the salesman replied, yes, sir, we have two quality refrigerator X and Y, but X is little bit higher cost than Y. And the customer asked, why? Why X is little bit higher? That means the refrigerator Y doesn't work well. Then the salesman replied, no, sir, both the refrigerator work well, but X is superior quality than Y. And the conversation went on. Meanwhile, the attendant brought a coffee, and you can see the conversation between the salesman and the attendant. One says, this coffee tastes very good. I don't mind paying extra for this. Another person saying, every day it is like this. I'm not finding any special in it. And the third one, I don't pay any extra because I'm not satisfied. So the attendant says, sir, you are paying for coffee, not for the quality. Yes, his statement is true. Quality is free. We are not paying for the quality. Again, we come across many situations where we pay different amounts for the same product, which means we have a coffee or we have a tea for 5 rupees or 8 rupees or 10 rupees. The quality, the quantity of tea is same, but the price is varying. And also, we have shown the movies, or we are generally go for movies. We pay the same ticket cost, but the quality or the sound system or the experience what we get may different from movie to movie. So here, the conclusion or the summary of this slide is the quality. We are not paying for the quality, just we are paying for the product. So coming back to the history of cost of quality, it is Joseph Duran who first devised the term cost of quality in the year 1951 in the first edition of Quality Control Handbook. And later on, the Feigenbaum, who identified 4 quality costs categorized into 4 categories in the year 1956 and published in Total Quality. Now, what is cost of quality? So it is a term which is mostly misunderstood and widely used. So the cost of quality is not the cost of producing quality product, but it is the cost of not producing a quality product. Now let us see what happens if a defective product is reached to the end customer. A firm has manufactured a product and it is shipped to the customer, and a customer received a defective product. What happens? So let us say he ordered a mobile, he received the mobile, he opened the pack, and he kept the charging and found that the cable was broken. What will happen in this case? So the customer has the chances, or he may go with liabilities from legal actions, or he may ask for repairs and replacement, or the customer or the organization may lose its goodwill. The organization may lose its business, and also in turn it will lose the market share also. And in few cases, the organizations may recall the product. And finally, it has to spend some amount on warranty work. So all these costs will come under external failure costs. Why? Because the company or the organizations are facing or expending costs on the failures which are encountered after reaching the customer. That's the reason these are called as external failure costs. So external failure costs arise from the rejection of the products or services by the customers due to poor quality of production. What we need to do in order to avoid the defective product? So before that, we basically see the recall of products. In the year 2009, the Toyota recall crisis has come at November 2nd. The mistake was in the foot pedal due to the entrapment. So because of this, the Toyota company has recalled all its cars back. And again, the second recall has happened in the year 2010, which was with the problem with the accelerator. And almost 5.2 billion vehicles for pedal entrapment and 2.3 billion vehicles for accelerator pedal problem were recalled. And recently, we also saw the news in the month of May, the Kia company has recalled all its cars. So, due to the failure of the O-ring, the entire space shuttle was blasted and damaged, where 7 crew members have been expired or died. So here, there is a comparison between the external failure cost, which was faced by the customer and also the seller. The external failure cost not only cost on the organization, it may lead some wastage or some damage to the customers also. The customers may waste their time, or the customers may lose their data. They may get frustrated and all. If the organizations don't want to ship the defective product to the end customer, what should the organization should do? It has to stop before it reaches the customer. How this can be done? The organizations can perform certain inspections so that they can ensure the product is not delivered to the end customer. In order to do that, first, the organization should identify the faulty good. Then the faulty good is identified, it has to rework. And when the organizations spare some time on reworking on defective units, there may be a downtime caused by quality problems. Again, there is a waste due to poorly designed process. All this leads to the costs. And these costs we are calling as internal failure cost. So internal failure costs result from identification of defects before they are shipped to the customer. So here, one good thing we need to observe is we are stopping one step before what we are delivering to the end customer. So both internal and external failure costs are the result of non-conformance. So under cost of quality, we have a cost of non-conformance. Both internal failure cost and external failure cost will come under cost of non-conformance. So cost of non-conformance is the cost incurred as a result of not doing the things right. So we can say it is a unnecessary amount spent. So what should we do? In order to avoid cost of non-conformance, what should we do? We need to prevent them. So there comes the new thing, that is a cost of conformance. So cost of conformance is the cost that is incurred in ensuring that the things are done right at the first time. That the organizations ensure the product is made or manufactured with the customer stated requirements. So as a part of conforming to customer stated requirements, organizations basically incur some costs, and those costs are called preventive costs. There is a quotation given by the Albert Einstein: intellectuals solve problems where geniuses prevent them. So by Philip Rothbay, it's cheaper to do the job right the first time than to recover from an error. So we'll look a few of the preventive costs that will come under cost of conformance. So preventive costs are the costs that are incurred on preventing the quality problems. So we basically preventive costs are indeed to prevent non-conformance to requirement right from the day one. So the emphasis on the prevention of defects in order to reduce the probability of producing defective products. So prevention costs are all the costs incurred in an effort to make it right the first time. So under prevention costs, the organizations has to establish a team. It has to plan for its quality. It has to provide training for its employees. It has to review design, and it has to develop, design, or install the quality measure maintain test equipment. In few cases, it has to conduct quality improvement programs. So all this will burden the organization in terms of finance. So these are treated as prevention costs. So every organization will spend good amount on prevention costs, because spending on prevention costs can save a lot of external failure costs and internal failure costs. And the next question is it sufficient to just have a prevention cost? No. Why? Because once the organization spend amount on prevention cost and they design the product, they give the training to the employees, they plan for the quality, but still there are chances where there is a chance of getting a defective product. In order to again avoid this, we have to establish an appraisal mechanism, a continuous feedback mechanism, whether the quality products are produced or not. So there comes another cost called as appraisal cost. So appraisal is act or the result of judging the worth or value of something or someone. So this is a cost spent to detect defects to assure conformance to the quality standards. So it includes quality inspections, product testing, performing audits to meet quality standards, worker time spent measuring quality, and equipment used for quality of product. So this will lead to cost which will burden the organizations. Both the preventive cost and appraisal cost will come under cost of conformance. So cost of conformance, something providing the product or services as per the required standards. So this can be termed as good amount spent. And summing up, cost of quality is something, it's a sum of cost of conformance and cost of non-conformance. And just now we looked, the cost of conformance is something, the cost of providing the products or services as per the required standards. Whereas cost of non-conformance is a failure cost associated with the process not being operated to the requirements. So here is a classification of cost of quality. So cost of quality can be divided into cost of good quality and poor. Again, cost of good quality is something cost of conformance. Cost of poor quality is cost of non-conformance. Again, both these can be categorized as prevention cost and appraisal cost, internal failure cost and external failure cost. So the figure which you're seeing on the screen gives an idea about which cost is encountered or which cost is spent in the timeline of production. If we speak about the prevention cost, it is basically spent before the production, and appraisal cost is spent during the production, internal failure cost is spent after the production, and after sales, the organizations will spend on external failure cost. And this is a production process, a general production process where all the four costs can be included according to their categorization. Here you can see a bar graph which tells the amount the organization spent on the individual cost if they encounter. And we can see for both internal failure cost and external failure cost, the amount spent is high. So in order to avoid that, the organizations need to spend a good amount in preventive and appraisal costs. And here I took a very simple example of a textile manufacturing industry having 4 departments: weaving, dyeing, printing, and stitching. So the preventive costs, here the preventive cost and the appraisal cost for training, maintenance, and yarn verification or cleaning, and for accessories verification. So all the organizations has to spend for preventing the failures. So the same thing applicable for appraisal cost too. And coming to the internal failure cost, the organizations have to spend for rework, overtime, production loss, raw material wastage, and so on. And these are the external failure costs, which we can see, that is container detentions and late shipments. Now let's look at trade-off between quality and cost. We'll go with the graph directly. In the graph, we can see three curves: a blue, and red, and green. So the blue curve indicates it's a cost of non-conformance, that is external and internal failure cost. And the red curve indicates the cost of conformance, that is both appraisal and prevention cost. As you go on producing the defective products, if we speak about the blue curve, as you go on producing the defective products, the cost increases. And at the same time, if you want to minimize the defect, if you want to produce a defect-free product, still the cost is increasing. That is indicated by the red line. So you have to maintain a balance between a cost of conformance and cost of non-conformance. And that balance is called as quality cost trade-off. Now, why to measure COQ? So what is the use of measuring cost of quality? Right? So here the organizations can understand the statistics of money spent on quality. They can set the targets to reduce the amount spent, and so on. So here is a simple case study where the table indicates 4 different costs: prevention, appraisal, and internal failure cost, and external cost. If you observe, as the amount spent on the prevention and appraisal cost, the total cost spent on the COQ has been reduced. And also, as you increase the amount spending on prevention and appraisal cost, the internal and external failure cost will reduce. So these are data pertaining to 4 years. So these are the key observations that we can conclude from the table. So this is a very brief overview of cost of quality. You can take up a case study by going to any industry, textile industry. You can collect the data and you can write a report. You can draft a report on what is the amount spent on external failure cost or internal failure cost and all that. Yeah, thank you so much. We'll go for a question and answer session.
Pradeep Garu, we'll have question and answer session in the end of the program. So now, fine. Thank you very much, Mr. Pradeep Kumar. Now I request our moderator Brahmohan Rao sir to introduce the next panelist.
Yeah, am I audible?
Yes, sir. Yes, sir.
Yeah, thank you. I now welcome Dr. N.V.S. Raju Garu. He is a professor in JNTU, Hyderabad, Jawaharlal Nehru Technological University, Hyderabad. Right, he is a very renowned person in mechanical engineering. Has published more than 20 books related to mechanical engineering, with titles like Operations Research, Instrumentation, Disaster Management, Optimization Methods for Engineers, Plant Maintenance, etc., etc. And he has authored more than 100 national and international publications to his credit. And he has conferred with gold medal for his paper, Make in India Issues and Challenges, in the 3rd International Conference and the 57th Convention of III India and SVP NIT Surat, Gujarat. And he is the recipient of the prestigious awards Shiksha Ratan Puraskar, Bharat Jyoti from IIFS, New Delhi, and Glory of India Medal from ISA. Vishishta Seva Puraskar by JNTU-H, the Best Citizen of India award from India Publishing House, New Delhi. And he has been visiting faculty for many of the institutes and in universities here, and he has guided PhD scholars. About 5 PhD scholars have completed their PhD from under his guidance, right? And a project guided by him bagged a silver medal in the year 1990 by Institute of Engineers and ISTE. So I now welcome Dr. NVS Raju to start his presentation, address the students. Over to Raju, sir.
Raju sir.
Thank you. Thank you, Dr. Ramon, and thank you, Kavita. This is my pleasure to hear some good words from you people. Thank you. Am I audible?
Yes, sir, you're audible.
Am I
And
audible?
the audience, I would like to say something like, you know, he's traveling right now, so his voice may not be as clear, and he may not be able to make a PPT presentation also, so we'll have to only hear to him, and probably we may get some disturbance also. I request the audience to bear with him.
No, I'm sharing the
he's traveling.
presentation, sir, from Raju sir, and I'm sharing his presentation.
Oh,
So,
great.
Yeah.
So Raju sir, you can now start, please.
Raju sir, are you there?
Kavita ji,
Sir.
you can run through the PPT in case I think he lost the connection.
Yeah, I'll just check with him, sir.
Hello.
Sir, you're audible, sir.
Am I audible?
Yes, sir. Yes, sir. Raju sir, you're audible.
Interesting.
వినిపిస్తుంది సార్. Hello.
Just few seconds. Hello.
Sir, you're audible, sir.
Hello. Hello, 1, 2. Hello.
Sir, you are audible, sir.
Okay. Corrected.
Hello, sir. Raju, sir.
Okay, madam. I'll go.
Yeah.
Yeah, the present topic is on Six Sigma and its applications, particularly for textile industries. So just now, Mr. Pradeep has discussed something about the cost. So let me just start with that. So anybody, generally when we need to sell a particular component or a product or any equipment or anything, obviously the customer wants at the lowest possible price. course, the producer wants more profits over it, but this you can achieve if there possible cost. So that's what Pradeep has given in the previous session. That's how to achieve this low cost. So this low cost can be produced by two determinants. One is reducing the rejections or reworks, by which we can reduce the cost of production and producing more in lesser time. So that you call productivity. So both put together, you can do, particularly in a bulk production, if you have to do, then the basic problem that more often we get is about the rejections and the reworks, and most of the times the defectives. So how to reduce this? Particularly in a bulk productions, this is a big task for the producers. So the Six Sigma quality program is one such technique, or it's not a technique, it's a philosophy, I should say, a philosophy that always tries to reduce the number of rejections and the number of defects. So, next slide, please. So the Six Sigma objectives are basically threefold. One is to reduce the defects, and the second is to reduce the cycle time and to enhance the customer satisfaction. Customer satisfaction is again the linked with the top two, that is reducing the defects or reducing the cycle time. Defect reduction is related to the quality, whereas the reducing the cycle time is related to the productivity. So both put together comes under this Six Sigma objectives. Okay, next. Fine. A step-by-step procedure for Six Sigma. Often people just speak on Six Sigma. What is Six Sigma? It is just improving the process at the source. Process at the source. That means including the fabric. For example, if you take textile industry, fabric purchase, fabric stitching, or fabric production, fabric embroidery, packing, shipping, everything designed to discard from the birth to the death of that particular product, everywhere, how to improve the process. This is one aspect of the Six Sigma, and by this is achieved by reducing the rejections at any stage. So if you reduce the rejections at the beginning stage itself, obviously this will prevent the rejections at the next stages. Then the second part is that minimizing the defects in the sewing sections, or reducing the defects during the packing, reducing the defects during say while stitching, or while yarning, or so and so and so and so. So a few examples I would like to give you here. For example, say in a mass production. In a mass production, suppose the saree production you have. So thousands of sarees you'll be manufacturing. Obviously, any small defect at any corner of the saree also will reject the entire saree. Instead, if you can reduce this defect at the very beginning level, the very scratch itself, then obviously you need not have to produce the next stages, and you need not to add the value, and you need not forego that particular value which you have added unnecessarily, which would have been rejected at the end stage. So that is why what my intention or the Six Sigma conceptual aspect is that you reduce or you prevent these defects at the very birth level. So when you are producing some thousands of things, it is very difficult to check each and everything, and at each and every aspect, and at every particular stage. Instead, what we do is we make it into lots, and if we make the process perfect to suit all those specifications, if the machine is perfect, that can produce in its specified values, obviously the product will be good. If the machine is good, product is good. And if the product is good, obviously it will sell well. But there is one particular aspect, that the human aspect. So if the human aspect is also well, then the product will definitely come out well. So when we often ask anywhere, so if is it a quality product, then people, the seller always will say that definitely, sir, it is 100%. But when you insist again, is it 100%? Then he may just say that maybe one in 100 may have a small defect. So if this is the way, you say that 1% of defectives in that particular lot. So if he is so confident that only 1 in 100 is having a defect, then you say it is just 99% confidence he is having. But if you have a confidence that 99.999, that means just 1 in 1 lakh, if you have this confidence level, then that is called Six Sigma level. More precisely, it says that 3 defectives, more exactly speaking, 3.4 defectives in every million objects. Per million objects, if you can produce 3.4 defects, then you have achieved the Six Sigma level. So this is what is the concept of this. So this you can apply it to your fabrics, say thousands of sarees produced. Obviously, no producer will try to produce a defective product. So he always wants to produce whatever that is produced, he wants to sell it out. So that is why he should not produce any small defect also. So eventually, this particular product will have no defect-free product in every million of the objects. Fine. The secondly, I can even say the second example, like each saree will have so many threads. Say a saree will have thousands of threads. So if every thread is right, obviously the total saree will be right. The saree, a fabric, or whatever it is. A particular cloth that you produce or the product that you produce will be definitely the better one if every thread is right. So if every thread is to be right, then at the very beginning level, when it is yarned or when it is pulled out from the cards and everything, at that particular instant itself, if you have, then we wonderfully have that particular yarns also 100% right. So obviously the product will be completely all right. So this is what is a chain process. Similarly, after yarn is produced or after the saree or a particular cloth is produced, then you need to stitch. So thousands of stitches will be there on every line or every. So at every stitch, a small stitch also definitely may produce a small defect. So at every stitch, if you are defect free, then this will be a Six Sigma level. So this is what is the concept. You can produce at any point of your production system. So next slide, please. Then conceptually, Six Sigma means 3.4 defects per million. 3.4 defects per million is called a Six Sigma level. That means 99.9996%. That means just 3 only in million objects. See, you see when you go and purchase some gold or something, he says 24 carat or 22 carat or 20 or 18 carat. What does it mean? Do you remember? Could you just observe this? A 24 carat means 99.99 pure gold, which indicates that in million grams of gold, only 1 gram, 1 milligram may be a defect, or maybe something. I mean, other than gold, that means iron or any or carbon or anything. So any other molecule may be there in that. That means what I mean to say is the defects are almost defect free. If it is 99.99% pure. Similarly, if you have a 2 sigma level, we call it as something like a 22 carat. If you have say the 1 sigma level, it may be something like a 18 carat, and so on like this. So you can understand the 6 sigma level production means the purity and the quality. So any customer wants a defective product, obviously, for his whatsoever the price that he pays. Definitely he needs a defective product. He doesn't pay for the defects. He pays only for the product. So that is why we need to produce a product that can give the value. So that whatever the value that you increase, that adds to the sigma. So given a chance, it is obvious that customer wants 100% defect. But 100% defect indicate 96. It is almost like 100. That means only you are leaving 3 defects or 3.4 defects per million objects. So the 6 sigma is one such approach that can achieve 3.4 defects only in every million of the products produced. This is almost like 100%. So next slide, please. We'll move on to the next one. So, okay, so statistically, we speak that a graph, if you draw between the production of the mix. So you can just find a normal graph, and this normal graph will have 3 sigma levels at the left and 3 sigma levels at the right, totally 6 sigma levels. So when it is between 1 sigma levels, that is called point of inflection. So in the point of inflection, the gap between these 2 points of inflection is the production that will have the highest value. Whichever is close to the central line, that will carry more and more values. So if you are approaching towards the central line, you are achieving to the 6 sigma levels. So at this graph, you can also split in 2 halves, like positive half and negative half. If that is so, then 3 on the positive sigmas and 3 on negative sigmas you can take. So that is also called a 6 sigma level. So, or otherwise, you can take from 0 from left to the 6 on the other side. So then you can say the it is a 1-tailed test or 2-tailed test in your statistics. You feel like you express that. So that upper specification levels and lower specifications levels you fix there, and then you count the sigma levels there. Next slide, please. This is just similar to your process capability graph. So process capability is calculated for the production on a particular machine, whereas this is counting the quality or enumeration of the quality on the products. So you can just find a small normal graph that depicts the plus or minus 6 sigma levels on left at the 3 and right 3, then nominal values at the center, that is mu, which is the specification range, and 0.001 on the right side you can see, and 0.1350 per ppm, parts per million. So this indicates the 6 levels from left to right, mean in the center. So the level that you go on to the level, whatever you go on narrowing this particular graph, you are approaching the 6 sigma to the highest level to that particular production. So the abscissa is the amount of production, amount of the defects, while the ordinate says about the amount of production. So in each production, if you can produce the least number of defects, that is the achievement of sigma. So how close you are towards the ordinate becomes the lean. How lean you are in your production is lean production. Yeah. Okay. Next. See, how you calculate this Six Sigma. Six Sigma is defects per unit. First, you have to fix up this. For each unit, how many defects you can expect at your confidence level. So let us call D by U. D for defects. U is, say, if U is the number of units that you are producing. Say for each lot, if you have 100, then defects per unit. If you say one defect, let us say, so 1 by 100 is your confidence level. So 0.01 will be the DPU. So once you find, once you fix up the DPU, then DPU by M, where M is the number of opportunities that you check. So that is in each production. Say for example, 1 lakh production you do, and you make this as one lot, as say 100 for each lot. Then you will have 1,000 lots. So you have 1,000 opportunities to pick up. So in each opportunity, how many defects you are getting is your DPU. So in DPU, for the number of opportunities, if you calculate, this is called DPO. That means defects per opportunity. Defects per opportunity. And once you calculate this DPO, then from that you calculate the Six Sigma levels. So next slide, please. That is called DPMO. DPMO is defects per million opportunities. Defects per million opportunities. So this defects per million opportunities you calculate at each level, and you fix up the levels. So these, if the levels are something like 3.4 DPMO, that is called Six Sigma. If your DPMO is 230, then you call 5 Sigma. If it is 6,200 DPMO, then it is 4 Sigma. Similarly, 3 Sigma is 66,800 DPMO. So hope you understand what is DPMO. I'll tell you once again. DPMO is defects per million opportunity, while DPO is defects by M into U, where M is the opportunity, number of opportunities, and U is the number of units that you. Thus, once you find this DPMO, then the level of sigma you can decide. And once you find decide this level, then you can rate your production at which level your production is. And 6 Sigma is the best, the world class production, while 5 Sigma we say good quality, 4 Sigma is average quality. Of course, 3 Sigma is not competitive, but still it is okay. So, but 2 Sigma and 1 Sigma are definitely non-product. Go to the next slide, please. Next slide. Yeah. The procedure for 6 Sigma, how we proceed, how do you estimate this 6 Sigma? For the production program or for whatever, whether it is production or distribution or sales, whatever it is, when you have the mass production system or in a bulk production system, then we have where the steps like this. The first step is you have to define what you are going to do and what you require, what are your inputs and what are the outputs that you are doing. So you define the system, you define the DPMO, you define the defect, and you define what is acceptable, what is defect. Then the second is, once you define, then you have to measure. The metrics also you should have. The measurable quantities, then only you can take. See, in quality, sometimes some things are measurable, some things are non-measurable. Some measurable things we call the variables, while non-measurable things we call attributes. Say, for a sweet, whether it is good or bad, you can only taste and tell, but you cannot say in any measurements. So this is an attribute. While the length of a saree, you can just measure. Say 5 meter saree or 8 meter saree. This is a measure. This is a variable. So sometimes it may be a variable. It may be an attribute. So the measurable things that you have to, the measures, the metrics that also you should be able to fix when you define a particular your product. Then you have to analyze them by taking the number of defects or what are various calculations that are given in the literature. Fine. After analyzing, then you have to think where you can improve this or where you can do the better things over this particular system. So improve, and then when you improve, obviously some control points you can observe, and at those points when you control, that completes a Six Sigma process. So at each cycle you can improve your sigma levels. Thus you can have this process is called DMAIC, Gemoic principle we call this for Six Sigma. Okay, next, if we see high percentage of B grade fabrics, for example, defined page, if you see high percentage of B grade products in a weaving mill due to high number of defects in the fabric. This is the definition we have, suppose, in a particular process. So once you define this, then why? What is a high percentage? This is that you got to measure that. Then high number of defects. What are the defects? What are called defects? When do you call it as a defect, and so on like this? These things you have to call, you have to define here. The objective is to reduce the percentage of this particular production. So this will be the definition of that Six Sigma program on particular that product. So next please. The second phase we measure. So when we measure, how many defects are you are getting for a particular product or the process or a particular component and so on like that. So that when we calculate, say for example, some total measure of defects, minor defects, etc. like that, you split and you calculate. Based on that, you can find the yield and the parts per million, and some formula we have for the Six Sigma based on the statistical calculations. Then we find the sigma level. Say for the given problem, an example problem I gave there, a sample problem in which the Six Sigma level is 2.27. Next slide. Yeah, then analyze. In analysis, various system, the various techniques already are available in your quality. 7 tools of quality we have, 7 new tools of quality you have, and the various things you have. So one such small thing I have taken here, something like fishbone diagram. So various types of defects, and for each defect, what are the sub defects, or whether quantitative type or qualitative type or attributes type or variable type, and so on like this. And for each type, what should be the reasons, causes? What are the causes for that particular defect, and what are the effects of that particular system? So if this is the cause, if you can identify, then that cause you can reduce or you can prevent, and you can produce the best of that. So this is the way cause and effect diagram will help us in improving the process. So that is why in your DMOIC, define, and then measure, then analyze, and obviously the next thing is that if you know the causes and their effects, you can then improve it. So DMAI, improve it. So once you improve the system, then that improved system is to be continued, and that you have to control the situations where you
Hello. I'm sorry, I think sir lost the connection. I'm just trying to connect him. Rammohan sir, are you there?
Yes, madam.
Sir, sir call is not getting connected. I think probably he lost the connection. So I'll just run through the slides and I'll try to. Would you like to just brush up, sir, from here, or shall I do it?
Yeah, I think how many more slides are there, madam?
I'm just looking at it.
How many
Actually,
slides?
sir has explained everything. Now these are only the examples like improve phase and control phase and merits and participants. Yeah, very few. I think we can just, I'll just complete it in a few minutes, sir. Now, I would like to continue from here on behalf of NVS Raju, sir. And already had explained the importance of DMAIC, that is DMAIC, where he had done till analyze phase, where the explanation is given with respect to textile example, where fishbone diagram has been explained with the causes and the effects, which are shown here. And once the analyze phase is done, then the measure phase is done, where actually the defects are occurring and how the defects can be corrected. So that for that also a small example has been taken up. Just a second.
So this is the result of the analysis phase. After the fishbone diagram, a Pareto analysis has been done here. So which shows the,
Sir, NVS Raju sir is joining in 1 minute.
So
Yeah.
yeah, I'll continue then.
Raju sir, we are able to hear you. Hello, Raju sir. Raju sir, we are able to hear you. Hello.
Hello.
Sir, we are able to hear you.
When the computer, object. Ranji. Hello.
Hello, sir. You're audible, sir.
Hello.
Hello. Hello.
Am I audible?
Yes, sir.
Connection cut.
Sir,
Hello,
already,
yeah.
Sir, yes, sir, you're audible.
Net problem వచ్చిందమ్మా net problem ఉన్నట్టుంది.
Yeah, sir, మీరు కంటిన్యూ
Could you
చేయండి,
ask
sir.
is Pradeep online? If Pradeep is online, you can ask him to continue, or otherwise you can.
Yeah, sir. I'll continue, sir. From here.
Only the last.
Yes, sir. I'll do it.
I think.
Yes, I'll do it, sir. Yeah, so now after the measure phase.
Yeah, please.
Yeah, after the measure phase, that is with the help of Pareto charts, the number of defects which are appearing at different areas of the manufacturing sector can be identified, and then they can be measured and find out which is the area which is causing more defects and which can be corrected. And after knowing the area which is creating the troubles or the defects in the process, the improve phase has to be taken up, where we are trying to eliminate the root causes of the problems which are creating the defects. Now, this improve phase, we are going to check for the root causes of the problems and analyze and try to address each and every problem that is causing that defect. And once that is being controlled, once that is being improved, and then we have to control that process with the help of various plans called as POCA yoke or statistical control process and failure mode and defective analysis process, which has been given an example here. And with the help of Six Sigma, we can reduce the number of defects which are occurring in the process, and which will lead to reduction in the production cost, and we can able to give this product at a competitive price in the market, keeping the customer focus in point. And this Six Sigma yields a very high productivity, and in turn the manufacturer will enjoy high return on investments. So this Six Sigma, the participants in the hierarchy in the Six Sigma is will have yellow belt, green belt, black belt, and master black belt, and the champion. So these are the hierarchy, or I can say the stakeholders of the Six Sigma. And this Six Sigma, once it is applied, implemented in the industry, will lead to the best quality product with a lower production cost. Thank you. Thank you, NVS Raju sir. And sir, moderator sir, please conclude the session, sir.
There's one more presentation, right? Giri
Yes,
Kumar?
sir. Yes, sir. Now this session, yeah, we have one more session. Now you conclude this session by NVS Raju sir.
All the three people, all the three speakers?
No. Only NVS Raju sir.
NVS Raju sir.
Sir, just a second, sir. Thank you, NVS Raju sir, for the session. Now we have one more session by Mr. N. Giribabu, the Deputy General Manager of Mohan Spintex Limited and the Compliance Head. Giribabu had completed his BTech from Usmania University College of Technology in Department of Textile Technology in the year 2001, and from then he had been working in the industries, working in various positions in the industry, and now sir is working at Mohan Spintex Limited as Deputy General Manager and Compliance Head. So in the field of textile and apparel, sir had a huge experience. I mean, I can say vast experience in working in the industries and understanding about the quality management systems at various levels. Now I request Giribabu sir to take over the session.
Hello.
Yeah, hello.
Am I audible?
Yes, sir. You can share your.
Yeah. Good evening, all speakers and participants. There were very good information given by my colleagues, speakers, and I'm very much grateful to Ayodhana sir, that he is my guru in Usmania University. So I'm sharing with him this platform. So now we will see compliances, importance of compliance in textile industry. I'll just share my screen. Is this visible?
Yeah, yes, sir.
Okay. One minute. I just want to find it. Yeah, first we see definition and scope of compliance. Actually, we have we have seen what is the cost of quality and Six Sigma importance in textile industry. And what is this Six Sigma? Six Sigma is a tool, like it will act as a catalyst to our procedures. What we have to do as a procedure in an industry to get success, to give a consistent quality for our final product. Now, to see this whole scenario, like where this complaints has come. Actually, long back in America, there are few industries where they were facing very huge problems of bringing everyone into one line. Like to follow the standards or to follow the procedures what they want to do actually to implement. So there were so many industries have come together under one roof, and they have decided, why can't we do a common compliance system? Like compliance is like conformity or agreement. It's a agreeable things. Like now the compliance means a continuous follow up on internal and external standards of businesses, best practices, code of ethics, anti-corruption, prompt risk prevention at the workplace, data protection, no money laundering. This means there are some internal and external standards in industry. Now, if we see an internal standard, if we tell that as a social compliance, there is a rule that from external standard, from government of India or government, state government, they say that as a SA 8000 compliance, you should not restrict while going any employee or leaving the organization, or on Sundays there is a off, so they can go on their independently, they can leave the premises, working premises. So many industries, they will provide hostels, dormitories and everything, so we should not restrict them actually. Now that is an external standard, what SA 8000, there should not be any, because restrictions will bring you as you feel that you are like you are not independent. So you're killing, you're hampering their independence. Now on the other side, if you give independence to workers movement, or there are so many young girls who are coming in the industry to work, if we give independence to them as per SA 8000, there is a chance of their security. So now this is a threat. According to external standard, yes, we have to follow them and not to restrict them of their going out independently on their own. Now we can write an internal standard to counterpart that one. Like we can take and consent from the parents, a letter that yes, my daughter is safe and secure, and she knows her movement cannot be restricted, and we will take all the charges of, means all the consequences of their movement. If we take a consent, that we make internal standard. SA 8000 standards are external, which is like general things. Now we will make a procedure to protect industry. We will make an internal standard. So like this is only an example in industry what we can make. So these practices, like internal standards are there, external standards are there. If we follow up these things continuously, these practices like best practices will be there, and code of ethics. Ethics is nothing but anti-bribery and human trafficking and taking bribes from employees, workers for the recruitments. So all these are there. There are many constraints are there, like many checklists will be there. So so code of ethics we can bring into that, and risk prevention, risk assessments we can do. In many areas risk will be there in working areas, so we can do risk assessments. And data protection, yes, usually there are control of documents, which is very important for a compliance, that data should be protected. And we can write our internal, actually there are like a standard is there around 2 years to 5 years. Like some customers are asking 5 years protection data. They may ask this 5 years, like what has happened in 2000, now we are in 2022. Now what data we have protected, what data we have done, which orders we have proceeded in 2018. They can ask that one. So we have to protect those data in a hard disk or in a files. And no money laundering, yeah, definitely this is a very strict rule what we can make. So these are only few things what I have mentioned here to explain that these standards, which are internal and external, to run the business successfully. And compliance with these rules can prevent and avoid wrongful or illegal conduct by companies, among other offenses. Definitely, when we write standards, when we write SOPs, standard ordering procedure. So when we define it, and when we give an awareness to all employees, you should follow this SOPs. Otherwise, you will not be part of the organization, because unanimously everyone's opinion will be taken and made an SOP. So if any new person will enter the organization, he has to follow the right now what the organization is doing. He should not bring his own SOP from other organization, and he cannot do on his own procedures. That will again deviate the unity. So yes, always if he is saying a best practice, then the current one, he has to discuss on the desk, and he has to keep a meeting, or he has to give suggestions to the suggestion team. They will take in a proper procedure, and we can include always SOPs can be changed. Always SOP can be we can do improvements in that. Now, what is compliance programs? A compliance program is a set of internal policies and procedures within a company to comply with laws, rules and regulations, or to uphold the business reputation. This compliance program is nothing but like, there are many policies before starting a business, definitely from managing director desk. Some policies should be made, like quality policy and ethics policy, safety policy, environmental policy. There are so many policies. There are like, I can say like around, we can make, there is a no limit, around 20 to 30 policies definitely we have to make. Why? Because these policies should be should give an idea of how management is going to deal that organization. What organization is doing with these policies. Policies gives an indication to an employee like how much they are thinking about the safety of the product, quality of the product, and the safety of personnel who are working in an organization. And the procedures, definitely we have to keep all procedures in place so that everyone will follow the same procedure. No one will speak his own procedure, or no one can include any new procedures on their own. Only a compliance officer or head of the compliance department is authorized to take the views of any new procedures are coming in line, and he can take intern management approval whether we can do this procedure and how it is going to be. Then we can implement that new procedures. Now, scope of compliance. Compliance means to ensure that business practice and processes are aligned to a commonly accepted norms. This is what I'm saying. All procedures will be given to each and every department, and they have to commonly accept the procedure. So this makes actually unity among employees. They follow standard procedures, and we get good results. Companies are expected to comply with an increasing number of regulations of different origin and complexity. Regulations that are required by law are given the highest priority. Nowadays, we know that working age, any human being, like a boy or girl, like above 18 years are eligible. When they come to 18, they are eligible for work. This is a law. Now there are some governments, like they are encouraging. Now they are introducing young labor. 16 to 18 are getting like young labor. So we can take 16 to 18. For them, we have to write a policy nowadays. How young labor should be handled. They cannot be put in any risk areas or non-safety. Even the procedures are there, even though we know that no, we cannot handle. Young labor cannot handle this work. We cannot put in that. So we have to analyze their risk assessments, and we have to write so many laws for them, young labor. And young labor should not be taken like more percentage. It should be like very nominal percentage of total employees. So young labor will be encouraged. We have to encourage young labor, and we have to write so many policies and procedures to handle them. So these are like, different regulations or complexities where we have to write in a compliance. What is the objective of compliance? Compliance is like the overriding objectives of a compliance officer should be to ensure that an organization has systems of internal control that adequately measure and manage the risks that it faces. When we write a procedure, when we define a procedure, we definitely take organizations of that particular working, like which product they are making and in which ambience organization is situated. And we cannot make any common procedures like from other industries. Yes, ISO standards are there, definitely. There are quality management systems, there are environmental management systems, and there are occupational health and safety management system. We call ISO 9001, ISO 14001, ISO 45001 respectively. So keeping in all these standards into consideration, we can define our own process flow procedures and to protect an internal, like we should have an internal control over the systems. So this will be the main objective of a compliance officer. Now, benefits of compliance for organization. If we follow our compliances and if we get all certifications like ISO standards, or if we use a Six Sigma tool to improve the quality. So all these things will give, company value. Company value will definitely increase. Employee morale will increase. Employee will feel very safe and secured, and he will be willing to work in organization very safely and a very long period, because his morals are kept intact and he will not be demoralized in any case. Business reputation in a market will grow and employee attrition will decrease. Employees will not leave the organizations. And consumer trust, we will definitely get a consumer trust. The consumers will feel very happy. All these procedures we are following. And hiking share values, when value of organization increases, definitely share values will increase. And legal notices, yes, any organization will be facing some of the legal notices, like they are dumping their sludge in the open grounds, that is a crime. If they are not disposing their waste materials in a proper way, in ethical way, or in an agreement way, those organizations will be penalized. So as a EMS system, as an environmental management system, they are having certain procedures to dispose the wastage. So each and every criteria which may tend to get legal notices from the governments or from other institutions, definitely we will be protected from the compliance if we follow. What are the different types of compliance? There are two main types of compliances, like corporate and regulatory. Definitely, we will tell that there are quality management system. There are technical complaints we call. Some will call like social complaints. Social complaints will come like RAP, SEDEX. All this will be like social complaints. And when we go to certifications like STEP certification, we call Go Green, like made in green label. And for that, Ocotech certification. These are all called licenses, certifications we call. So there are different varieties of compliances industry will follow, but mainly we have to categorize these two types of compliances, corporate and regulatory. Regulatory, which external standards are followed as per laws, rules and regulations. Wherever the external government is involved, those rules are involved. They are called regulatory things. Like chemical regulatory is there, wastage regulatory is there. So many regulatories are there. And now corporate is like what you will feel, you will keep standards, what you will follow. Now there is a process flow chart. Now there is a product, we are doing bed sheets. So when we do bed sheets, there is a procedure from cutting section to packing section. So when we go with an order of a procedure, like after trimming, we have to do checking. If I tell that this is a procedure we need to follow for a better quality. So that comes under a compliance procedure, process flowchart we have set. Nowhere, no one can do first checking, then trimming. So wherever our standards are given, our standards are fixed, our flow is fixed. So they have to follow that procedures for a betterment. So these are like some of the corporates. In social corporate compliances will come, regulatory compliances. In quality management system, corporate compliances will come and regulatory compliances will come. So now a quality management system also says that you have to protect your people like who are working. If in any technical complaints comes, he will not only go with the quality standards and the quality reports. And definitely that is a part, but how you are checking, how you are doing, how you are cutting the lay. If if a person who is going to cut the lay, if he is not wearing a metal gloves, that also will give a blood spot on a product. There is a critical thing like, we have to understand as a social complaints, we are telling that you have to protect your hand. Employee hand has to be protected from the blade, moving blade. Yes, that is a social complaint. At the same time, when a person gets hurt, that blood will come on the product. That whole layer may go to the blood, go to the so many layers, and blood stain is a very big defect in a quality. So as per the technical complaints also that is wrong. So these are like we have to defend so many things are there which come in a common as a social complaints and also technical complaints. So that's what now giving a safety. This is a regulatory complaints. When it comes to protect your employee is a regulatory. Government says that you have to protect your employee, your worker. So that comes regulatory. So we have to do regulatory compliances and corporate compliance. That's why this is the main segments where we can we can segregate these corporate and regulatory. What is a corporate compliance? As I said, the process of making sure your company and employees follow all laws, regulations, standards, and ethical practices that apply to your organization. And elements of corporate compliance program. See, as I said, policies and procedures are there. Chief Compliance Officer, Compliance Committee is there. Like what I am dealing now right now is all 4 units of organization. I am dealing with compliances. Any compliance, any certification comes is under me. And so I'm the one of the element of the compliance program. And my team is going to be a committee, compliance committee. So whenever technical comes, whenever social comes, definitely all people will attend that one, and we will see that audit that pass. And education and training, definitely a training education is a element like where awareness is given. To all employees for procedures, for follow-ups and everything, and reporting system. Monitoring and auditing. The reporting system is like what quality reports are there, what HR reports are there. So many reports will be generated. So what is the progress? You will come to know about the progress of your systems with the reporting. And monitoring and auditing. So we do monitoring actually, how people are doing reports, how they're doing the systems and everything. And enforcement is there. Why? Because if enforcement is there, then only employees will obey the systems, and they will follow the standard systems together in one line. And responding to issues. Whenever any issue comes, people have to respond. Any employee has to respond to the issue. Who is responsible for corporate complaints? A company's board of directors is responsible for overseeing and managing the company's business activities, including efforts to manage risk and ensure compliance with applicable laws and regulations. Definitely, a higher management should be involved. Otherwise, if we involve middle management, like what we are doing, like DGM level or GM level, whatever. If management person is given in a compliance rule, means they have to establish all standards of the compliance. He will be feeling like responsibility of completing those, and there is a pressure. There will be a good pressure or good follow-ups will be there. The downline people, if management person is given a responsibility to accomplish all the compliances. What is regulatory compliance? Regulatory compliance is a set of organizational processes, policies, and procedures that support compliance with the laws, rules, regulations, requirements, and guidelines established by lawmakers in the jurisdiction in which the organizations operates. That's what. There is a local jurisdiction, there is a central jurisdiction. So whatever the government says, we first follow the state government. Why? Because that is a direct governing rules. So laws, whatever they give, if any changes are there in rules and regulations and laws, definitely we have to follow. Organization should follow those. And any central government rules and regulations are there, any conflicts are there, definitely we have to give notice. So all this comes under regulatory compliance. So what is an example of regulatory? Environmental pollution, what I said, like waste disposal and protecting your land from any chemical spillage, ETP areas, effluent treatment plant, you have to follow in a good way so that there will not be any sludge spillages and wastages are there. So labor against child labor or other employment regulations, minimum wages laws. This is a very common word, minimum wages. Definitely we have to follow as a regulatory. Regulations requiring truthful labeling of organic cotton and made in India. This is what step certification. This is one kind of, if we want to go our product with a made in green, so we have to take step certification. For step certification, again, we have to go for OPTEX. A combination of OPTEX 100 and step will give an organization permission to put their products as a made in green. Compliance techniques. Yeah, these are the techniques like people usually uses to follow employees as a compliance. Actually, the foot in the door technique is the first one. Whenever we see we have to catch a lift. Okay, so we have to enter the lift. Now to enter the lift, now doors are closing. You have come into the last moment and people are inside. You have to enter the lift. So what you keep, like either you keep, definitely a person will know that there is a sensor to the lift doors. So you will put first leg. You will not enter directly your body. Your body will not go. So there will be harm. Like sometimes they may stuck. It may stuck or it may give a large damage. Or at least you put, there is a shoe is there which protects your small even though it touches. So now you will put a foot. Now the sensors will act and the doors will get open. Then you will enter completely into the technique. That is the foot in the door technique. Like now to make people to understand about compliance, if you want to follow the procedures, the procedure is a lengthy procedure. Now you have to maintain, for example, you have to maintain domestic and export demarcation in a warehouse. So now there are 10 warehouses. If you think, now if you put this procedure and if you tell your supervisor or head of the warehouses, if you tell, you have to demark, this procedure is there, internal procedure, this is not regulatory thing. So for internal procedure, you demark your domestic goods and export goods. That is a laborious process. Already you are following the procedure. Now you have to introduce the new procedure, which is a laborious process, and sometimes there is a reluctance from the working people. Now what you can say, you cannot say like 10 warehouses you have to implement. Just what you say, first you put a foot. First you tell that, why can't you do this implementation in one warehouse and show me? He will think, okay, out of 10, one is okay, we can do. Okay, he will take 2 days and he will do. Now next line. Now you can tell that please follow for other 9. This is very good implementation. We have done a very good job. So why can't you do for another 9? Now what happens? Definitely he will come with a negotiation. Okay, one by one I will do. Okay, you do one by one. You take the time. The first opening sentence you will put very small request. Then it will open to the large request. Like you have to make this technique to fulfill your compliance. Now the door in the face technique, this is just opposite foot in the door technique. Like what you have to do is, for this one example is there. Now you have to make organic cotton separate files. And there is a separate checklist is there to follow organic cotton. That everyone knows that this is a for traceability. We will do organic cotton, Cocotex labeling, ordering, and all these are separate sections we can do. Now, if I tell one procedure like we have to make a separate these things. Already you have proceeded for years together. Now to make it separate is very difficult. Now how you will do? First you will get that all 100 or what you have done, you have to make separate sections and you have to implement these systems for traceability for all 100. If you tell this, definitely that is a laborious process and very huge amount of time will be taken, and your merchandiser will tell that no, it's not possible. Definitely it's not possible. Then slowly you will give an offer. Okay, not for all orders, we just follow this for organic order. Enough for me. Now he feel very happy. If you go and tell all organic cotton, you separate it from 100 orders and you do it, then he will tell some stories like, oh no, we cannot do that and all that. So first you put the door, means door in the face. First you put a huge one and you just decrease your request so that we feel very happy. Okay, at least that is not there, at least this can be done. So these are techniques in textile industry. And the low ball technique is a very good technique. Like you are giving an offer, like for example, now you want to sell your fabric. So you will, a marketing person will offer to customer about the fabric, where he will give a quotation like 180 rupees or 200 rupees. Now he wants to sell in 210 rupees with example of 5% GST and all that. He will tell that 200. He is very happy. Once negotiations over and once they give the order, slowly he will put a word that, sir, this 200 is not included in GST. GST is separate. So this is a low ball technique. Like suddenly if you tell 210, will be a negotiation. He knows. So slowly he will tell 200, then he will put that it is not included in GST. Now we have to include GST, so you have to give 210. So those small techniques are there. In compliances also we have to follow these techniques to make people come under one roof and follow all procedures and policies. Yeah, thank you one and all. These are like some of the compliances, objectives, scope, and techniques what I would like to share with you. Thank you.
Thank you very much, sir. We understand that the Six Sigma concepts or the lean concepts, if it has to be applied in the industry, then the compliance also have to be taken into consideration before we apply the Six Sigma concepts in the industry. Thank you very much, sir. Now I request our moderator for today's webinar, Professor Dr. Ram Mohan Rao, sir, from National Institute of Fashion Design, Madhapur, to conclude the session of all the four panelists who have given the session.
Yeah, thank you, Kavita ji. Before I start summarizing the talks by the panelists, I would like to say a few things. Like it is National Institute of Fashion Technology. It is not fashion design. It is a typographical error in your brochure or minute-to-minute thing. So this is one I need to tell you. And another thing, I've been following the chat in the chat box. One Dr. Ethirajan Askaran. He is very active and he has put a question in the chat box that what is zero defect and what where is zero effect and where is zero defect, which is not covered in this seminar. So if he is there in the still there online, then I would like to answer him that, sir, the scope of this webinar is Six Sigma for textile and apparel industry. So zero effect, zero defect, see. And another question he asked is that whether it is Six Sigma is still relevant. See, first we reach the defect level of 3.4 in 1 million opportunities. Then we go to the zero defect level. So which is the next level. Probably once we achieve this, we probably will get into that level. And coming to the summarization of these things. Am I audible? Am I audible to you all, please? Can you please respond?
Yes, 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 sir.
Yeah. So starting with, I would like to thank Professor Hayavadana sir, Professor NVS Raju, Professor Mr. Giri Babu, and Dr. Pramod. If I am not right, Pramod. I noted down the name. NVS Raju and Pradeep. Sorry, I misspelled it. Pradeep. So Professor Hayavadana started it. It had given a very great start. Started with the concepts of early Six Sigma. So he first defined the Six Sigma and the number of various levels of the different approaches, like how it is felt by different people. Like Six Sigma has many meanings, like it is just treated as a symbol, like you see in the statistics, like sigma stands for the standard deviation. So it is represented by a symbol. So for many of the people who are mathematical oriented, will just look at it as a symbol. And for the people statisticians, it is a measure of variance. The sigma stands for the standard deviation, and it measures the variation, and the variance measures the performance of any process. Okay, and then the benchmark or goal. See, the Six Sigma sets a benchmark for the industries to standardize their processes, their manufacturing processes. Then standardize their products, standardize their supplies, standardize their processes, standardize their outputs, and reach their customers with the right quality product. And Six Sigma is also a philosophy. It is not just something that you just follow a methodology and just implement. It is not that. Unless you have the total employee involvement, it's not possible to implement the Six Sigma. Right? So these were the approaches where Hayavadana sir was inherently trying to explain. Right? And he was talking about it, that it is a process which mentions, which gives the discipline that the business to design, improve, and standardize the processes. Okay, and he was also talking about the evolution, like the history of this thing. So it is a statistical procedure. So when it started with the normal distribution curve, which was discovered during 1800, early 1800, and then process control during early 1900s, and today, and in 1980s, late 1980s, like the Six Sigma concept has been introduced by Motorola company. It has started in an incidental way where one of the Japanese companies has acquired one of the units of Motorola company, which was making television sets. And within a very short span, they could reduce the defects produced to 1/20th%, 1/20th percentage. So which has triggered the Motorola company to look into, introspect into its procedures, and started looking at how to improve the processes so that they will also achieve that level. So it triggered, and they have constituted a committee with their top level employees, and then the Six Sigma concept has been worked out. And today we see Lean and Six Sigma. So it has joined with the Lean manufacturing as an approach, as a philosophy, and Lean and Six Sigma are now going together. So this is how it got evaluated, which has been again discussed by Professor. Inherently was that, and he was also, Professor Hayavadana was also discussing about the levels: Six Sigma, 4 Sigma, 5 Sigma, etc. And Six Sigma is the highest level, which can be the benchmark for most of the industries, like 3.4 defects per million produces our opportunities. Okay, and the current level of industries, say 4 Sigma, where around 6,000 defects produced per million produce, right? Which is at the current state, how it can go up to the reach the 3.4 defects per million. What he was saying is that he says that Y is a function of X and Z, where X has the deterministic production factors like 3Ms and 5Ms, whatever are there, and the Z are probabilistic factors like aerodynamics, other factors which are not controllable by the industry or anybody. So he was talking about that set in which he has discussed about the ergonomics part, in which he has discussed about the ergonomics part and training the skill levels of the operators and the moral levels of the operators, etc., etc. And he was also talking about the push and pull production system. Like push is manufacturer produce owner-oriented production system where whatever owner produces, the manufacturing company produces is pushed on to the customer, where the pull production system, what customer demands will be produced by the company. So where critical to quality aspects are being considered, the voice of the customer we will see is heard. So the entire industry's manufacturing process is reoriented towards producing what exactly the customer wants, is what the approach was. So he was talking about the standard times, calculation of SAM values and SMV standard allowed minutes, which is a specific terminology for the garment industry. And SMV standard minute value is also a specific terminology for the garment industry, which is used to calculate the targets, hourly targets or shift targets for the garment industry. And why is it so difficult to implement in garment industry is that the garment industry is a very garment or textile industry to a major extent is a very labor intensive, and the product is also not standardized. You can see in terms of raw material, there are many colors, there are many patterns, there are many textures, etc., etc. And in terms of a garment also, there are many different designs and styles, which makes the product a very highly variable, and the raw material also highly variable. And the number of operations in between the raw material to the final garment are also very high in number, and the duration, the total SAM value, the total production time will be in minutes. So you can see the cycle time is very, very less, which leads to a labor intensiveness. And when any industry becomes a labor intensive industry, it is very difficult to get a consistent quality of the product. So an automated industry will definitely give a consistent quality. When you automate the machinery, when you automate the complete production process, deploy all latest machinery which works without human intervention, the quality of the product produced will be consistent. Whereas if a human being does, it depends on a lot of other factors, cultural, socio-economic, etc., etc., by which the variability in the production will be very high. So achieving consistent quality in a labor-intensive industry like textile and apparel is very difficult, right? So he was also talking about the 6-3-5 concept, where 6 people sit and do brainstorming on 3 ideas for 5 minutes to develop a solution to the given problem. And he was also talking about Yamazumi chart, a belt chart. I'm sorry. And he was also talking about the re-engineering and reverse engineering. So to improve the quality, once all the quality parameters have been set and you're not achieving the desired quality level, then you will have to relook at your entire process, and probably you have to start from the scratch to build your machinery from the beginning. So that's what was. That was what the concept of re-engineering. And reverse engineering, take the best and start looking at what happens in that and try to incorporate, build in your processes. So the traditional approach of cost plus profit is the price, but the lean concept says price minus cost is the profit. So you reduce the cost, you increase your profit margin. And he was also discussing about the different tools used for implementing Six Sigma, like DMIC approach, 5 Whys, 5S, housekeeping or whatever you call, value stream mapping, etc., etc. He was also talking about that, and regression analysis, Pareto charts, FMEA, Kaizen, Pocoyo, Kanban, etc., etc. He was talking about, and he was also talking about the tact time, where the total available time by the total production time, which will tell you what customer wants and how much customer wants. Yeah, then coming to the next presentation by Mr. Pradeep, he was talking on the cost of quality. So he initially started with the definition of quality, and he says that the cost of quality is cost of conforming quality and cost of non-conforming quality, both together. And he was talking about history of quality, cost of conformance and cost of knowledge. I was just going through what I've written about him. Methodology, he discussed about external failure costs, he discussed about the internal failure costs, and then he discussed about the methodology to improve the internal failure costs, internal failures, reduce the internal failures, and how to reduce the internal failure costs and external failure. And he spoke about the total quality control. And he has done some textile case study, discussed about that. And then he discussed about a case study of ABC Motors. And then comes the Dr. NVS Raju. He was talking about the Six Sigma applications in textile industry. So he was focusing more on reduce the rejections and reworks and produce more in the given time. So the productivity can be improved by, as per him, what he was talking about is that the productivity can be improved in two methods. One is you deploy more number of machines, or you produce the same amount. You produce more out of the given or the available machinery. So that can be achieved by increasing the input or reducing the input and producing more out of given things. So the productivity improvement is one of the techniques by increasing the production. So he was talking about that, and he emphasized on the fact that the Six Sigma is a philosophy, not just a method. So he was morely focusing on reducing the defects, reducing the cycle times, and increasing the customer satisfaction. Yes, then coming to the Giri Babu, the last speaker on Six Sigma, he was talking about the compliances. So he discussed about compliance programs, set of internal policies and external policies, and they talked about the objectives of compliance and how they have to be implemented, and the benefit what you derive from the compliances. Then different types of compliances, corporate level and regulatory level, and different techniques which are used for implementing the compliance, like first foot in the door in the face in the door in the face, and the low bar techniques. This is a summarization of the speakers, the panelists. Now I would invite the questions from the participants. Any questions?
I think Mr. Bhaskaran has raised his hand. If he's there on the screen, you can please ask the question. Prithirajan Bhaskaran. I think he has left, sir. If anybody else
Yes, sir. He had questions raised, but I believe that I have answered one of his questions, which was put in the chat box.
Okay.
Yeah.
Yeah, maybe if he's satisfied with that answer, it's okay. Otherwise, he can still raise his hand and any panelist can answer. Thank you, Bhaskaran ji.
I think he's not there in this.
He is there. He's answered. He answered, sir.
Okay, sir.
Is he
Thank
there?
you.
He has put his chat box. He has mentioned his.
Okay.
Yeah, satisfied and okay. Yeah.
Thank you, sir. Dr. Ram Mohan Garu, Professor of NIFD.
National Institute of Fashion Technology.
NIFT.
NIFD, no? National
FT.
Institute of,
Yeah.
is
So it
a
was a
very famous
typographical
and
error in your,
a very famous institute on the main road of Madhapur, sir.
Yeah.
I know it, opposite, I think that Sri Krishna building, something like that. Very good, sir. And actually, I seek apology from all the speakers and moderator also. I had another parallel meetings with some CEOs of startups regarding our 2-day mechanical convention on 9th and 10th of this month. And that is the reason I could not full year, but I am very much interested in this Six Sigma topic. But kindly apology, accept my apology for fully not attending this thing. But I am fortunate to listen to Raman Rosar. He has given the excellent summary of entire what happened and what was the talk went on. It's really nice, and our institution is really privileged to have such professors and industry people who have come all the way, and madam has arranged for such a this thing. I think even at one time it touched 45 to 46 strength.
Yes, sir. Yes, sir.
So it's a really good webinar. And in fact, I would like to physically conduct any such webinar in future rather than a webinar, because webinar doesn't count any value for me. I just only one number saying that I've conducted one more program. But I will look forward, madam, in the future.
Yes, sir.
We will have a very good program, one full day, 1-day seminar.
Seminar.
Yeah, you arrange 4 speakers is sufficient for full 1 day also. I am really happy. I thank Professor J. Hayavadhan Garu and Mr. N. Giribabu and Dr. N.V.S. Raj Garu, Mr. Pradeep Garu, and none other than that the excellent moderation by the Dr. Ram Mohan Garu, Professor of National Institute of Fashion
Technology.
Design, Madhapur. Fashion Design. He has written
No,
there,
technology, sir. Fashion technology.
But in his name, NIFD is there. Anyway, no problem. National Institute of Fashion Technology. I'll correct. It is still design, it is shown. Anyway, thank you, sir. Thank you for all these things. And really a wonderful program. I have one more meeting now again because organizing and technical committee meeting now starts for my convention. And they all already professors are waiting. So I thank you, sir. And now I think the program was very, very excellent and very good, informative. I could gather from even the question what they put on the chat box also. And madam, please see that it is tell SARS also. The next time we should have physical program in our
Definitely,
auditorium.
sir.
They should visit our auditorium also. I don't know
Definitely,
how many of them have seen our
Yes.
auditorium is very good, because we may not be aware. So that will be good. And unfortunately, I think King Sukhsen could not properly convey our cottage chairman, who is a very good orator, Ranganath. But Ranganath also could not attend because he was out of Hosur. And then our president Hemant Thakreji is having some family function. He could not attend. And I really thank our Professor Sadhan Chandra Ray, chairman of the Textile Engineering Board of Institution of Engineers, who is always by virtue of Ray and Reddy, we sit together in the council side by side. Thank you, sir, Ray sir, for giving us an opportunity for Telangana State Center to conduct this webinar. And always I appreciate the King Sukhsen, who worked with me when I was Director General. He's a very sincere boy and very, very prompt in action, this thing. And he'll attend any day, Saturday, Sunday, he doesn't mind. Anytime you call, he attends to the queries from the centers. It's such a nice boy. And now I hope, I think the program went on very well, and all the even participants also enjoyed the talk of this Six Sigma for textile and apparel industries. Now, may I request Dr. Professor Kavita Garu, kindly say vote of thanks, and then followed by national anthem.
Yeah, sir. Yeah, I, Dr. Ayadhya Kavita, Joint Honorary Secretary and Committee Member of Textile Engineering Board, would like to propose vote of thanks Respected Dr. H.O. Thackeray, FIE President, IEI, Professor Sadhan Chandra Ray, Chairman, Textile Engineering Division Board, IEI, and Dr. G. Ranganathan, FIE, Chairman, CATE, IEI, and Engineer B. Brahma Reddy Garu, FIE, Chairman, IEI, Telangana State Center, and Dr. Ram Mohan, Professor, National Institute of Textile Technology, Madhapur, panelist Professor J. Haivadana, Vice Principal and Head Department of Textile Technology, OU, and Mr. N. Giribabu, Compliance Head, DGM Mohan Spintex Private Limited, Dr. NVS Rajugaru, Professor and Head Department of Mechanical Engineering, JNTUH, and Mr. Pradeep Kumar Garu, Department of Mechanical Engineering, Kamla Institute of Technology and Science, Karimnagar, and convener of this event, myself, galaxy of the eminent personalities who are present here, past presidents, past chairmen, council members, committee members of IEI, Telangana State Center, corporate members of IEI, media friends, ladies and gentlemen, good evening to all. On behalf of Telangana State Center of IEI and on my own behalf, I convey our sincere, profound thanks to Dr. H.O. Thackeray, FIE President IEI, and Professor Sadhan Chandra Ray, Chairman, Textile Engineering Division Board, IEI, and Dr. G. Ranganathan, FIE Chairman, CATE, IEI, and Engineer B. Brahma Reddy Garu, FIE Chairman, IEI, Telangana State Center. I also thank the dignitaries, past presidents of IEI, past chairman of IEI TSC, past honorary secretaries of IEI TSC, council members, committee members, corporate members, and other who made it convenient to attend the event. Even I would like to thank all the students of University College of Technology, Department of Textile Technology for attending this session and making the event a grand success. And I also thank the representatives of media. Thank you one and all. Thank you very much, sir.
Thank you.
National anthem, who will play, sir? Mute lo unnar sir meeru.
He cannot play. He is not having mic over.
Yeah. Then thank you. Yeah. Thank you very much, sir. Then. Yeah. Bye, sir. Hello.
शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय जय जय
Jai Hind.